Hey everybody, welcome back to my channel. In this video, I'm going to try to explain all of chemical engineering in, 10 minutes or less, or your money back.
In the last video, we talked about chemical engineering, the different branches of engineering, and all the different fields you can go into. I won't be talking about the careers in this one, so namely we'll be talking about the academics. The main thing that I want you to get out of this video is that calculus, chemistry, and physics are really fundamental for the sciences and engineering, and if you mix all of those together, that's the perfect combination for chemical engineering. So with chemistry, of course, we're going to talk about atoms and the periodic table. We're going to talk about conservation laws like the conservation of mass and energy, and dimensional analysis. With physics, we'll be discussing vectors, Newtonian mechanics, and thermodynamics. And with calculus, we'll be talking about functions, which is in algebra, pre-calculus like the concept of limits, and derivatives and integrals. Some may find these concepts very simple, and some may find these concepts very difficult. Whatever level you're at, please try and stick until the end of the video because I want to show you the main concept of chemical engineering. The first thing that we have to talk about is none other than atoms. Atoms are great. They're made of protons, neutrons, and electrons. Atoms are stuff. They have mass, they have charge, they have energy, and they clump together to form these things called molecules that undergo chemical reactions. And just about everything is made of atoms. We're made of atoms, you're made of atoms, the computer is made of atoms, the air that you can't even see but gives you life is made of atoms. There are these tiny little balls swirling around everywhere and they make up everything. That's great, except that's not true because atoms are not tiny little balls swirling around everywhere. Atoms are made of electrons, and electrons are described by wave functions, which means electrons are particles and waves, and atoms are made of electrons, so we are all both particles and waves. We're just going to pretend that atoms are these tiny little balls. And so we can talk about different types of atoms like the helium atom. So the helium is the second atom. It has two protons, two neutrons, two electrons. And so what I want you to do is memorize the mass of each of these particles. We have the mass of the proton and the mass of the neutron. They're approximately the same. Notice how extremely small it is, 10 to the minus 27 kilograms. That's an almost incomprehensibly small mass. Notice that the mass of the electron is even smaller. It is 2,000 times smaller than the neutron and the proton. We can also have the atomic mass unit to derive Avogadro's number, which is a very large number because atoms are so small. We're going to have so many atoms in 1 mole of a substance. And we should also know the approximate radius of atoms are within the angstrom range typically. So the radius of a helium atom is 1.4 times 10 to the minus 10 meters, which is about 1.4 angstroms. And now that we know about atoms, we can move on to none other than the periodic table. For as many as you can, I want you to know the chemical symbol and the atomic weight. And if you want to start somewhere, start with these 12. You're going to for sure need hydrogen, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, sodium, magnesium, potassium, and calcium. You can start with those 12. All I want you to do is just go on Google and search up each of these one at a time. What are they used for? How do you make them? How do you process them? Can you buy it? Is it dangerous? What is it gonna do if you put it to water? Is it gonna blow up in your face or is it gonna give you nutrients for your body? And now we're done with atoms for a while. Let's talk about conservation laws. So conservation laws is simply just stuff cannot be created or destroyed. What kind of stuff? I'm saying mass can't be created or destroyed, energy can't be created or destroyed, momentum can't be created or destroyed, and charge can't be created or destroyed. Oops, did I give it away? I certainly did. These are known as transport equations, mass, energy, and momentum. The next thing I want you to do is unit conversions, and I don't know how to teach this other than through example, so here's your next homework assignment. Using the internet and a calculator and your brain, that one's very important. Use your brain. Try to calculate the number of atoms and protons and neutrons in 100 kilograms of water. Calculate your age in seconds and calculate the distance from the earth to the sun in inches, okay? Again, you can use the internet to know like how far it is in miles, let's say, but I want you to calculate it by hand using a piece of paper. And notice how I said the number of atoms, protons, and neutrons, that's mass. Your age in seconds, that's time. And the distance from the earth to the sun, that's length. So now we can talk about dimensional analysis. So we have the base dimensions, mass, length, and time. Mass is the amount of matter in an object, length is just the distance from 2 points in space, and time is time. These are so fundamental in physics that almost every single quantity you'll ever calculate in physics has to deal with these three quantities. And notice how the units are in parentheses and the dimensions are in brackets. The dimensions are going to be in brackets and they're capital. So these are the three base dimensions. There's actually 7 total base dimensions. There's temperature, electric current, luminous intensity, which is light, and the amount of stuff, which is in moles. So I want you to go through each of these, contemplate them, try to observe them in your everyday life, and then we can build them from here because now we can derive essentially the rest of physics. For example, by combining 2 length dimensions, we can obtain the second dimension, which is area. By combining length and time, we can obtain speed and velocity. There's also these things called scalars and vectors, which we'll talk about in a second. So your homework for this section is to finish the rest of this table and just continue thinking about this for the rest of the day. The next thing we're going to talk about is physics. So we're going to talk about Newton's laws, we're going to talk about vectors, and thermodynamics. In classical mechanics, we deal with objects in space moving as a function of time. So space is just 3D space. We live in the 3-dimensional world, but we can also imagine that we're literally in space. So let's say that there's a ball in 3D space, and for whatever reason, it starts moving just like an inch. And if it starts moving, it's just going to move on. Just keep on moving forever. If there's no other forces acting on this ball, it's going to keep on moving forever. That is Newton's first law. Newton's first law is just saying that an object in motion stays in motion unless acted upon by another force. So that means that if you have a ball and you put it in space and there's no other forces acting on that ball and you just give it a little tap in space, it's going to go on forever until the end of the universe. What is Newton's second law? So Newton's second law is F equals ma. Force equals mass times acceleration. So force is in newtons, mass, as we said, is in kilograms, and acceleration is in meters per second squared. So if I give you a ball that's 10 kilograms and the acceleration is 10 meters per second squared, then the force is going to be 100 newtons. So if I give you 100 newtons applied to a ball that's 5 kilograms, what is going to be the acceleration? Okay, that is Newton's second law. If you have 2 of these quantities, you can calculate the third one. Okay, so what does that mean? Let's say we have the same ball and we apply a force on that ball in space, then that ball is going to start accelerating. So accelerating is kind of like speeding up over time. So that's Newton's first law, an object in motion stays in motion. Newton's second law, F equals ma. And Newton's third law is, for every action, there's an equal and opposite reaction. Meaning, if you punch someone in the face, it's going to hurt their face just as much as it's going to hurt your knuckles. Now we can talk about vectors. Vectors are these things that look like arrows, and they're just math. So in physics, we talk about vectors and scalars. Scalars are just numbers. We already talked about several scalars like mass and time. Vectors are arrows whose length is proportional to the value of the scalar number with a certain direction. What does that mean? Let's talk about it. So here we have a 3, 4, 5 triangle. How do I know it's 3, 4, 5? Because I put 3 boxes on the height and 4 boxes on the bottom, and we know from some math we can calculate the hypotenuse. So that is a 3, 4, 5 triangle. So with some math, we can draw this on an XY grid. From now on, I want you to think of the world in terms of math. Everything is on this XY plane. So the length is 4 and the height is 3. So this is going to be described by a point 4, 3. So we have one really important equation, which is the Pythagorean theorem. So the Pythagorean theorem says that 3 squared plus 4 squared equals 5 squared. But in general, we have the length squared plus the height squared is going to be equal to your hypotenuse squared. So your hypotenuse is going to be the radius of a circle that's rotating around the origin. Okay? But these are all scalars. If you calculate the Pythagorean theorem, those are scalar quantities. We want a vector equation. So all we have to do is define r as a vector. See how I drew r as a little vector with a little arrow? Vectors are just arrows. So now the vector r is 4 in the x direction and 3 in the y direction. So in Newtonian mechanics, we talk about Newton's laws, an object in motion stays in motion, and F equals ma. Notice how force is a vector, and acceleration is a vector. Do you see the little arrows on top? That means they're vectors. That means those are arrows described by the magnitude and direction of the force and the acceleration. Mass doesn't have an arrow, so that means mass is a scalar. And the third law is for every action there's an equal and opposite reaction. So that's pretty much all of Newtonian mechanics in one slide. We can also talk about conservation laws. Remember when we said that stuff can't be created or destroyed? Well, now we're talking about thermodynamics. So in thermodynamics, there's 3 and a 0th law. So the 0th law is just simply saying if I have something hot and I put it next to something that's not hot, eventually they're going to reach the same temperature. If you're warm, if your body is warm outside and then you start to go outside in the cold, your heat in your body is going to leave your body and then enter the environment, and eventually your body and the environment will reach equilibrium. So we're talking about heat transfer. Thermodynamics, think about heat and temperature. Then also the first law. Again, the first law of thermodynamics is the conservation of energy. Energy cannot be created or destroyed. It can only be transferred from one form to another, like heat transfer and all the types of energy we'll for sure talk about in the future. The second law is basically saying that the universe is lazy and there's something called entropy that governs the heat death of the universe, and there's about 1,000,000,001 different ways of saying the second law using equations or logic. And the third law is saying that absolute zero is not possible. It is not possible to freeze the atoms in a molecule so slowly such that they have zero temperature. That's just not possible. Now we talked about chemistry and we talked about physics. Now we can talk about calculus. So calculus, there's a lot. So I'm going to have to make this one really short, and then we're going to for sure jump way more into this into the future. So number 1 is about functions, and then pre-calculus, and then just going straight into calculus. Okay, very briefly, like I said, I'll be going over this in the future. When we go through school, first we learn addition, and then we learn its inverse, subtraction. Then we learn multiplication, and then we learn its inverse, which is division. Then we get into powers, and their inverse, like powers like 3 squared is 9, so, and then the inverse is square roots. So the square root of 9 is 3. When you learn calculus, you learn about these things called derivatives and integrals. You see that integral? Do you see that little s, that squiggly s thingy? I hope that looks familiar if you're watching this on my channel. That is called an integral. It is a symbol that denotes calculus. It is an operator that acts on this function. Oh look, we can talk about functions next. And derivatives are the inverse of integrals. And as soon as we learn the relationship between integrals and derivatives and realize how they're inverses of each other, we can combine everything that we talked about and invent chemical engineering. But in this video, we're going to be just talking about functions. So a function is just a machine or a computer that takes a number and follows a unique set of calculations and displays another number as an output. What do I mean by that? So let's say I have number 1, and then the function says 1 squared, calculate 1 squared, okay, that's just 1. And then another number is going to be 2, calculate 2 squared, oh, that's 4. Let's take another number, 3 is going to be 9, the input for 10 is going to be 10 squared, which is 100. We can put in any input, we can say any input, negative 14, and say negative 14 squared is 196. And again, we can say any input, the function is x squared, so we're going to say that the output is going to be x squared, okay? Then what we have to do is write down these numbers and then put them on a graph. So again, if we have 1, it's just 1. 2, 4, 3, 9. 7 squared is 49. So we're going to go 7 on the x-axis and 49 on the y-axis and put a little point there, and we keep doing that. And see how it's like forming the shape here? Let's add more points just to be sure. So what if I go in between 1 and 2 and in between 2 and 3? So we're getting a little bit more detailed here. So we have more points that we're plugging in an x, and we're plugging in x to get our function x squared, and we're plugging in these points. And we do that so many times, we do that even finer. We're taking the limit. We're taking the limit as these get closer and closer to each other until finally we get a full function as our output. So a function is just a machine or a calculator that takes a number as an input and generates an output. as a graph. So functions are graphs. And now we can talk about chemical engineering. So let's say we have a city. So the city, let's draw a box around the city. And that box is the boundaries within the city walls. And let's just get rid of the city. Just look at the box. We're going to have our inputs and our outputs for the people coming into the city and the people leaving the city. We can also count the number of people that are being born in the city and the number of people that are dying in the city. So here it is. Accumulation equals in minus out plus generation minus consumption. So if I want to know the accumulation, I'm just going to plug in this equation, and that's going to be the accumulation. So what does that mean? So if I say that there's 10 people per year coming into the city and 5 people per year leaving, and every year 100 people are born and every year 50 people die, we're going to plug in accumulation equals in minus out plus generation minus consumption. The net amount of people entering and leaving the city per year is 55 people per year. So that means every year there will be a net increase of 55 people within the city walls. Let's change the numbers a little bit. Let's say that, I don't know, 5 people per year are entering the city and 10 people per year are leaving the city. Then there's going to be about 10 people per year that are born and, I don't know, 100 people per year that are dying. Like lots of people are dying. So then we're going to have accumulation equals in minus out plus generation minus consumption. So we're going to have negative 95 people per year. So that means every year there will be a net decrease of 95 people per year within the city walls. Say it with me. Accumulation equals in minus out plus generation minus consumption. Accumulation equals in minus out plus generation minus consumption. One more time. Accumulation equals in minus out plus generation minus consumption. Just about every equation we use in chemical engineering is that concept. So I hope you understand what happens when you mix together calculus, chemistry, and physics. You mix that all together, you put it in your input, your output is going to be chemical engineering. And that is chemical engineering in a nutshell. Thanks so much for watching this. That's the end of this video. Your homework, which is optional of course, is to teach someone else. In fact, if you want to make a video and share it, I'll be more than happy to feature you on this channel. Let me know what other main topics in engineering or physics or chemistry and calculus that I really needed to explain in this one video, and then I'll explain them in the next video. That being said, thanks again so much for watching this video. What are some classes that you've taken or are currently taking that maybe are really fascinating, maybe they're really difficult, maybe they're too boring for you? Let me know. Thank you.